Hi, this is Paula J. Welcome to another episode of Secure Hacks Weekly. Today I'm with Christian. Hi, Christian.
Hello all.
Perfect. So Christian is our infrastructure architect, and we've got a very interesting subject for you today, which is related with the health of Active Directory. So we were thinking together about how many things are out there in Active Directory to be checked for. Are there many?
Yes, there are quite a bunch of things you should check on a regular basis. However, we try to select for this video the top 5 most important from both health perspective in your environment and also from security perspective. The first one I will be talking about is a delegation of privileges in Active Directory.
Nice. Yeah, this is a very good subject. It's quite often misconfigured.
Yes, this is quite often misconfigured, and actually that can lead to exposure of your Active Directory. So sometimes you delegate a lot of privileges, for instance, to help desk administrators or people responsible for contact with your users. And sometimes you leave your Active Directory widely exposed to those persons who shouldn't be responsible for configuring your Active Directory. So it's something that you should really focus about, and for sure you should have a good documentation about it. And I will also provide you a nice PowerShell script that can easily report all the delegated privileges in your Active Directory environment.
And that's just one, by the way. And we were talking about 5. Anyway, so guys, if you want to see the remaining 4 and the first one as well, stay with us and let's begin.
Exactly.
Cool.
Okay, so as I mentioned in the intro with Paula, today I'm going to talk about one of the 5 most important things that need to be checked in the Active Directory. The rest of videos are coming up soon in the same playlist. Okay, so let's dig into our today's topic, permission delegation in Active Directory. Often quite overlooked security topic. However, it's very important to understand how permissions are working in Active Directory, what are the paths for potential attacker to compromise our environment, and how we can defend ourselves from potential attack. So let's start. Active Directory permissions are similar to file system permission we set every day on our servers. UI is almost exactly the same. The permissions names are obviously a little bit different, and we set the permissions in almost exactly the same way. The problem with Active Directory permissions is actually the fact that many Active Directory administrators don't have enough faith in themselves, and they are afraid of making any modifications because they think they will break stuff. This is not true. You can safely modify the permissions in Active Directory if everything is well planned, well thought before you implement the change. You should be good to go. Why the permissions are so important? Because the permissions determine the rules for reading our objects and their attributes, updating, creating, and removing the objects from Active Directory. Before you start setting up permissions, it is important that you understand your environment and determine which information is sensitive for you. I will give you a short example here. Maybe for me, it's not important that all users in my Active Directory can read phone number attribute of other users in Active Directory, because this information is not sensitive in my case. However, I can have multiple other attributes in Active Directory where I store sensitive information, and those attributes I would like to protect. But here your mileage will vary. Every environment is a little bit different, so you have to spend some time on proper design. When it comes to permission management, don't be afraid. If you planned everything well before, it's not a big headache. You just have to set up a proper permission and inheritance schemes in your Active Directory architecture, and you will be set for several years ahead of you. No issues here. There is a problem, however, when it comes to built-in GUI tools that are offered by Microsoft. Unfortunately, they have a lot of limitations. This is why you either have to learn how to use DS ACLS tool or PowerShell. My personal favorite is PowerShell for this task, but your tool is your choice. On top of setting permissions that will either allow or deny an operation on AD object, we have to think about auditing. This is also set up in the same UI. Auditing rules are actually crucial because if you set them correctly, your Windows operating system can keep track of all operation in Windows security event log, and you can easily write a script or integrate a SIM to alert you or report all the changes you made in Active Directory. This is not a topic for today, but it would be nice if you think about it later on. Okay, so let's dig into technical stuff. How Active Directory permissions behave and what they are. Each AD object stores permissions as a security descriptor in anti-security descriptor attribute. What security descriptor contains? Information about inheritance. Then we have DACL, which is access control list that consists of ACEs, which define the permissions the user have to this object. Then we have system access control list that also consists of access control entries that defines the permission events that will trigger both success and failure audit message. So things that would be recorded in security event log. Those two lists consist of ACE. Today we are focused on DACL. Each access control entry consists of the following properties. We've got a trustee, so this is a seat of a user or group to which ACE applies. Pretty straightforward. For instance, user Christian. ACE type. This determines if ACE is allow access or deny access. Object type. This is stored as schema ID GUID of an object type to which ACE applies, or writes GUID if this is a property set. Obviously, we don't work on GUIDs as humans, so normally we have to resolve the GUID to a textual representation. Then we have another property called inherited object type. This is a schema ID GUID for type of a child object that can inherit this ACE. Access mask defines a type of access, read, write, for instance, and flags specify inheritance settings. I hope this is pretty straightforward. What can be a little bit cryptic are those object types, but don't be afraid. It's very simple to realize how it works. Object type user has one GUID, a very long unique string, object type computer has different schema ID GUID, and so on. Now, the next thing when we are talking about Active Directory permissions is to know the difference between inherited and explicit permissions. Explicit permissions are permissions that are directly applied to an object. And inherited permissions are permissions that are applied at some level of the tree above the object and flow down to an object and its children. So they are inherited. Pretty straightforward. And here there is one myth that I would like to debunk straight away. Trainers, consultants often say deny overrides everything. Nope, it's not true. There are certain situations, and I will show you that on a demo, where deny doesn't override everything. When we are talking about the permissions in ID, you have to understand three rules. Deny ACs override grant ACs of the same type and point in directory tree. Okay, so if on a single object on the same level we have allow and deny, deny will win. However, there is also a second rule. Explicit ACs override inherited ACs. So the permission that is mirror the object would apply in plain English. And the last rule is that inherited ACs are hierarchical, and inherited deny applied to a container will be overridden by an inherited grant applied to containers nested below it. Pretty straightforward. Active Directory is tree-like structure, and also it applies to inheritance, how it flows through the branches. Okay, so let's move to the first demo of today, demonstrating that deny doesn't always override all. Let me start with creation of test OU perm and test OU perm child. Pretty straightforward PowerShell commandlets. Let me show you graphical representation. Okay, nice and clear. Now let's play a little bit. Let's move to test OU perm. Security tab. Let's click Advanced. Add. I will select my test user named Bob. Okay. Let me clear the default permissions. Yep, everything is clean. I will change the type to a deny, and I will deny Bob from creating computer accounts. Create computer objects. Okay. Apply. Okay. So generally this should prevent Bob from creating computer accounts under test OU perm. Now I will modify test OU perm child. I'm not going to disable inheritance, so let me just add Bob here. Come on, Bob. I will clear all the permissions, and I will allow Bob to create computer objects. Apply, OK, and OK again. I will move to Windows 10 machine. I will check who am I. I'm Bob. Let's try to execute this commandlet. And as you can see, computer account was created. Let's create another computer account. However, in different path. This is directly under test OU perm. And as you can see, I wasn't able to do that. So remember lesson for you, explicit permission will override inherited permission. So although Bob is prevented from creating computers here, when we allow him to create computer accounts here, as you can see, he is able to do so. Okay, let's move back to presentation. The major topic of today, delegation permissions. There are three ways to delegate permissions. The first one is pretty straightforward, however, we don't have too much control over it. When we install a software, often the software installation will imply that some of the permissions will be delegated. A good example here is the installation of Exchange server that will delegate multiple Active Directory permissions to groups related to Exchange server. Okay, we should be able to report all those delegated permissions, but if we would like to install everything without changing the default proposed by Microsoft, we don't have too much say here. Obviously, we can on our risk modify the permission after the installation. The second type of delegation occurs when domain administrator or another privileged account delegates the permissions manually. Okay, so this is not often done, but from time to time we perform manual operations, and here the rule also applies that we should perform proper change management for that, because those operations usually are completely valid. The third and the most common type of permission delegation is the usage of delegation of control wizard. This tool will allow administrators to delegate management of certain types of objects to individuals or group within the organization. So common things like creating a support group, help desk group, delegating a help desk operator that sits near its users. So Active Directory that is divided on geographical regions, those things would be common. However, this tool is far from perfect. The wizard is useful only when we need to delegate clearly applied permissions, like for instance, create computer accounts or create users. However, it's not useful when we would like to specify deny permissions. There is no such option. Okay. Another problem would be to remove previously delegated control. And this is what actually attackers are hunting for. You delegate the permissions, you grant too many permissions by mistake to someone, but because there is no nice wizard to revoke the permissions, you just keep them without any modifications hanging for a red teamer to abuse them. Also, the wizard doesn't allow me to delegate control over individual objects or apply special permissions to branches of my Active Directory tree. So there are some limits, it's good to know them. Because of this limitation and the fact that many Active Directory administrators don't like to work with PowerShell or command line tools, quite often uh, I see during the audits an inaccurate control of permissions we delegate to certain users. And also I see quite often a lack of general concept that can lead to whole Active Directory compromised by an attacker. So, as I told you at the beginning, a good plan, good architecture is crucial here. Another shortcoming from Microsoft, there is no easy way to report all permissions on Active Directory objects. Obviously, you can use some tools provided by third-party vendors, or you can use a custom PowerShell script here, and this method I will demonstrate. This is a script you should analyze after this episode of CQURE Weekly, and you should try to build up using as a baseline this script so you can create a really nice custom tool. Let me just walk you through the code of this script. It's not long, it's quite straightforward. Okay, so first we select those system GUIDs because I really would prefer to see user computer instead of a system GUID. So this is done here, and here I'm gathering the GUIDs of extended rights. Okay, this would be nice for me to have a textual representation. The next step is pretty straightforward. I'm defining an array of containers. So I'm starting with a domain. This is also an object on which I can set permissions in Active Directory. Then I'm moving to containers, object class container, and then I'm gathering all OUs in my environment. And the final step is to loop through all OUs and containers gathered here and just apply a standard command let get ACL with the prefix ID, obviously, to get Active Directory object. GUID resolution, and finally export to CSV. Okay, I will show you final result. As you can see, from a small example domain, quite a long script. But you can simply add filtering, and for instance, let's report the permissions of user Bob. Okay, and the same can be applied to any column of this report. So here we can see that Bob have some permissions when it comes to computer accounts and also some user accounts. Okay, so the script and the usage is straightforward, and I would highly recommend you to gather such information and compare it over time. You can do it on a schedule every month or every quarter, depends on your environment, obviously. On top of it, you can also adjust what Active Directory rights you gather, because only certain rights are interesting for an attacker. And let me describe the most interesting rights in Active Directory that I can use during a pen test. Force change password. Okay, this gives me an ability to change user password without knowing its current value. So this is a password reset. Add members. This is an ability to add members to Active Directory group. And obviously, if the group is privileged, like domain admins, for instance, then it's pretty straightforward to win. Generic all. This is basically a full control over Active Directory object. Even in GUI, it's written full control if you would be interested in setting it through GUI. Possible attacks here: change password, add user to a group, Kerberos attack. Okay, three most common. There are potentially some other. Generic write. This is an ability to write to any non-protected property of an object. As you know, every object class in Active Directory has multiple properties, and here I can modify them. Example attacks: add a member to a group, Kerberos attack. Those two should be enough. Here, another two of my favorite permissions to abuse. Write DACL. This gives me an ability to actually write a new DACL on an object, which means that I can modify any permission. Write owner, another interesting permission, because I can grant object ownership to another security principal. And a small hint, when you would be using that during an attack, object owner can override what is written in DACL. Okay, so actually this renders DACL ineffective for object owner. And the last, all extended rights. This permission give me an ability to perform any function defined as extended right. You can use my example script for auditing permission to review all potential extended rights. And here examples would be again changing password, adding to a group. And very nice permission, last but definitely not least, is a DC sync. This gives me an ability to become a domain controller. Obviously, I won't become a normal domain controller, but if I have DC sync right, it means that other domain controllers will think of me as a domain controller. And this exposes the environment to a bunch of potential attacks. Okay, so we are done with the theory. Let's move to the practice. I will show you how a small mistake with delegation can dismantle your whole organization. Let me create new organizational unit for test called Berlin. Let me create a new user under Berlin OU. Okay, we're good to go. Tom is my new domain admin working in Berlin. So let's add him to domain admins. Perfect. Now, let's say that I want to delegate control over Berlin OU to Bob. Bob is a support person working in Berlin location. He will be helping users with their problems. Okay, so let's select Bob. and Bob will be responsible for creation, deletion and management of user accounts, and also for resetting their password. As we all know, people tend to forget their passwords. So this is quite standard set of permissions that we delegate to support or help desk personnel. Let's next, finish, perfect. Okay, so let's move here to Windows 10 machine. Okay, and I can see user Tom. I don't know his password. However, I'm a help desk guy, so a guy with a lot of powers. So let me reset his password, and I will set his password to hash capital EDC for RFB. Okay, let me just kill it, kill it, kill it. Let's open CMD as user Bob. Who am I? I'm Bob. Bob is even not a local admin on this machine. So let me run CMD as user Tom. Ha, who am I? Right now I'm Tom. It wasn't an issue because I just reset Tom's password. Let me quickly create a backdoor user and let me add my backdoor user to domain admins group. Okay, perfect. Now, okay, this was pretty straightforward. You all know the commands, nothing fancy. However, this is not a good practice when attacking, because the next day the Tom will come to his job, he will realize that the password was changed. And Tom is a smart guy and he will start digging into the logs. What the hell happened? So what a smart attacker can do? A smart attacker can pull one more trick from his sleeve. We'll do something like this. So we'll be using Mimikatz. I will execute, maybe I will enlarge it a little bit for you so you can see it better. Font 20 should be much better, and maybe I will change the colors. Much better. I will do ls a dump dc sync for user Tom from domain CQURE lab. Okay, let me scroll a little bit. Okay, and what we can see here, a password history for user Tom. So NTLM0 is my current password, NTLM1 is my old password. So let me copy my old password, actually Tom's old password, and I will use lsademp module again, but this time with set and TLM. User again Tom. Here the switch is server, so we provide a domain controller on which this command will be executed. So DC01 CQURE lab in my case, and we provide the alt and TLM hash. We are good to go. Let me exit, and here you have to trust me that I will open CMD with old Tom's password, which is standard Microsoft CQURE password. Ta-da! It worked. So try it at home if you don't trust me. And obviously, the last step would be just to show you that we have a user called backdoor, and this user is a member of domain admins. Okay, that would be all for today. I hope you like it. So have a play with what I showed you and test security in your Active Directory. Till the next time.